Okay, in this tutorial we're going to take a look at the inverse trigonometric functions, and those would be the functions you see on your calculator that say instead of sine and cosine it'll say like sin and raised to a power of -1, or cos raised to a power of -1. Okay, and so what it's doing is kind of like just like addition and subtraction and multiplication and division, or inverses all of each other. Then the same with here. Normally we say we're taking the sine of an angle and we're getting this opposite length, or we're taking the cosine of an angle and we're getting the adjacent length. So in the same vein, we can use these inverse functions to take a length and find the angle directly. So in the previous video I showed you how to use an arctangent function, which takes the opposite and the adjacent side, or the sine over the cosine, to get an angle. But let's try this. We have a function here that's pi over 3 for starter. I mean an angle that's pi over 3. So first thing to note, that if I was this is the same as a 60-degree angle, all right? Or let's say a simpler version just for a second. A 45-degree angle is the same. If you took the sine of 45 degrees, it returns 0.707. So if I was to come into the Python expressions and just type sine of 45, it gives me an answer of 0.85. So I know something's wrong, and that's because by default the argument takes an angle in radians. All right, so for this 60-degree angle right here, it's the same as pi over 3 radians. So when you're using your expression, if I type in sine of pi over 3, then it gives me a value of 0.866. So that is going to be 0.866 is going to be this length, or the sine value. So let's go verify that in edit mode. Come down here and we'll look at the lengths, edge length. Let me see if we can see it. Well, there it is. It says 86.602 centimeters. So if I didn't have my metrics on, if I had none, there it is, 0.866. So I'm leaving it in metric mode because that's how I like, it's really important to have units of measurement, at least for me. Maybe not for you, but for me it's absolutely critical. Okay, so now that we have that, now what if we just take this same value and just take the inverse of that, since we know that? So I took the sine of this angle to get a length. Now I want to take the inverse sine of the length to return the angle. So in type-wise, instead of having to type sine to the -1, it's just typed arcsine like this. So you type in arcsine of 0.866. I'll try and be precise just so I can get it as close as possible. It's 866 like that. So I take the arcsine, and there it does. It returns an angle in radians. Okay, so that would be 1.047 radians like this. So let's go look at this let's go look at the angle instead of the length. And there it is. You can't see it. It's right underneath that thing, so I can't just move this out of the way slightly. And there it is, 1.047 radians. Okay, so then in the same way we could take the cosine of pi over 3. Down in here we'll say cosine has to use radians, pi divided by 3, and it gives us a length of 0.5 for this edge. You can verify that that's 0.5 is going to be that length along that cosine edge. So then if I know the side of this, then if I take it, I'll just do the arc cosine of 0.5, and it does the same thing, and it returns me that angle like this. So that's some of the other features built into Python, which are really powerful. So as you get better and better at using it, then you can quickly prototype your work right down here using these Python expressions, and it really helps. I mean, it makes your work quicker and more productive. All right, and some other things that are built into Python that's really cool is, say, scientific notation when you want to represent really big numbers. So maybe I want to represent the number, maybe not a big number, but the number 5,000. Well, 5,000, or let's say the number 1,000 for starters, is the same as 10 cubed. So 10 cubed, or 10 to the third power, is the same as 10 times 10 times 10. So 10 times 10 is 100, times 10 is 1,000. So in scientific notation, if I wanted to represent the number 5,000, I could just write it as this. I could say 5.0 times 10 to the third power. Now this doesn't, you go, well, that doesn't save me a lot of work because I'm only using my number to start with was only 4 digits. 5,000 is only 4 total digits. So, but that is the same as the number 5,000. 5 times 10 to the third, because we're really saying 5 times 1,000 is equal to 5,000. However, you have really giant numbers, say like in chemistry, maybe you're doing 5 times 10 to the 24th or the 82nd or something way out there. Suddenly this type of notation becomes super important. And so there's different ways to represent it. This is traditional scientific notation like this. In computers, if you take a look at my calculator videos for my geometric drawings and my texture design program, if you take a look at the computer stack over on the left hand side, computers represent it differently. They'll say 5 e to the number, so e plus number, but it's every one represents it differently. So in Python has its own way to represent scientific notation, and so to say 5,000, I could just say, if I wanted to add 5,000 plus 2,000, I could say 5,000 plus 2,000 like this. It gives me 7,000, but I could do it in scientific notation Python wise. I could just say 5e3 plus 2e3, and there it is, 7,000. So there's scientific notation. That'd be the same as 5 times 10 to the third power, like this. Alright, so all these little things really help, and they're a lot of fun once you get used to them. Okay, well that's it for now, and I'll see you in the next lesson.